Hello, everyone, and welcome to our webinar, Hurricane Ian, Reflections, Lessons Learned, and Its Legacy of AMS Weatherband's 2023 Jamposium with Jamie Rome, Kim Klockow, Kim Wood, and moderated by Doug Hildebrand. As we get started, I'd like to address some of the guidelines for the webinar today. For those of you who were in the previous one, you'll know how this goes. We're going to be using the Q&A to collect questions from the audience. So if you do have questions during the webinar, please put them in the Q&A at the bottom of your screen. And please do put in questions in the Q&A at any time during the webinar. We will answer them when we can. I'd like to introduce today's moderator, Doug Hildebrand, who was our opening speaker today. Doug is the National Weather Service Preparedness and Resilience Program Lead, leading the Weather Ready Nation Ambassadors, Storm Ready, and Skywarn programs. He's also the AMS Chair of the Weatherband Committee, a member of the newly enlisted Committee on Spirituality, Multi-Faith Outreach, and Science, and a former commissioner of the Weather, Water, and Climate Enterprise Commission. With 20 years of experience in the National Weather Service, Doug has held various roles, including a communications specialist, policy advisor, and research and innovation lead. Thank you, Doug, for joining us today.
Thank you, Eric. And I'll tell you, the first hour of the Jamposium went very quickly. And my prediction is this webinar will go just as quickly. A lot of great discussion so far. And we have three very accomplished speakers for you all today, and a really interesting, sort of seminal moment back in late September of 2022 with Hurricane Ian. And so we're going to have this very conversational, back and forth. But I want to invite everybody who's participating here. If you do have a question, don't be shy. Reach out to us. We'll try to answer every question. And if we don't get to you within the 1 hour confinement of this webinar, we'll certainly look to answer those questions offline through the Weatherband chat functions and whatnot. Our first speaker is, really, worked this event from beginning to end. Jamie Rome is the acting National Hurricane Center Director. He is also a fellow North Carolina State University grad. So Jamie, awesome. And really looking forward to your comments coming up in just a little bit. Then we're going to pass it on to Dr. Kim Wood, who is professor at Mississippi State University, specializing in, guess what? Tropical meteorology. And she has her PhD from the University of Arizona. So we go from NC State to Arizona, and then we got to hit the middle of the country. So Dr. Kim Klockow McLean is a social science researcher at NOAA's National Severe Storms Lab, NSSL, and leads the Behavioral Insights Unit, which is one of my favorite names of an office. And Kim earned her PhD from the University of Oklahoma and is joining us there from Norman. So to kick things off, right off the bat, Jamie, tell us your Hurricane Ian story.
Hey, Doug, just want to make sure you can hear me okay?
Absolutely.
Yeah, and I'm not going to tell everybody Doug's nickname from North Carolina State University. Look, I got him. I got him to turn red. All right, good. So Ian is obviously a very, very impactful weather event, hurricane landfall, on the heels of several other big impacts. In fact, the last 5 years have been exhausting for those of us working in hurricane disasters, just begging for a slow season at some point to breathe and take it all in. Ian provided a couple of lessons learned, and just for context, I've been doing this for 23 years, and it's every hurricane provides an opportunity to learn and evolve. And Ian, it was no different. There were some folks that sort of cast Ian as somehow different, or some people went so far as to make it out as some sort of governmental failure. But 23 years of hurricanes, that's just not the case. It's an opportunity to learn and to grow, but I wouldn't go so far as to make it out as anything unlike other hurricanes in terms of that. So there's two lessons learned that I think are worth repeating here. There's often an insatiable appetite for a narrative in the first few days after a disaster, and that desire for a narrative often pushes people beyond data and facts, which is a little disappointing for a physical science-based community that grounds itself in fact-based decision-making. And it takes a long time for a disaster to fully reveal itself, both in the terms of the societal impacts and in terms of the magnitude. So like the peak winds, what were the strongest winds in Ian? What was the highest storm surge and where did it go? And you see a lot of rhetoric in the first few days and weeks that doesn't end up being entirely accurate once the full breadth of data comes in. So that's not unique to Ian, but you certainly saw it play out. And the one thing that we really need to have discipline and wait for is to hear from the emergency managers that were on ground, right at, it impacted, and they can't really say much right away because they're working the storm. They're working the storm. The response and recovery component often lasts weeks and months. I mean, you can still see from the news how the impacted community is still struggling to get up back on its feet. And so those frontline workers are still very much working the disaster. But the other one is the other lesson learned is we have got to get more comfortable talking about what is the most important life-saving tool in the toolbox, and it's not the cone, it's evacuations. We have to be able to talk about and train people whether they're in an evacuation zone or not in an evacuation zone before a storm ever forms. And then when a storm is bearing down on the community, the ability to talk about who has been asked to leave. That is the most important life safety information out there, the biggest tool in our toolbox. And we often become infatuated with things like the European versus the GFS or whatever. And we just blow right over the most important information out there, which is the evacuation order itself. And so those are the two big ones for me, Doug. And so I'll leave it at that, so we allow time for the other speakers and the Q&A.
No, some very poignant points made there, Jamie. Thank you. All right, Kim Wood. I know we have two Kims as panelists, so I'll have to go with some other identifier as well. But Kim, you have the microphone.
Thank you. I do have some slides here, kind of a nice jump on from what Jamie was talking about. We do tend to focus on the cone and whether places impacted were inside that cone. This is a graphic that illustrates that the forecasts were very good. We have the darkest blue in the area where the storm ended up going. So the cones were overlapping, but people, it's one thing to see these maps. It's another thing to know what to do with that information. Have you been asked to evacuate? Do you know what you need to do when it comes to evacuations? And it's tough because tropical cyclones are not points. They are large storms. And one of the things that really got me while watching Ian and then watching it make landfall and traverse Florida was its size. This is a satellite image showing the storm as it was approaching landfall. And what I've overlaid on it are the estimated extents from the National Hurricane Center of where there might be hurricane force winds, which is here in the yellow, and where there might be tropical storm force winds, which is here in the blue, or blue, it's blue later, here in the pink. But the thing is, it's not just, do you know whether to evacuate or not, but when do you go? And what types of preparations do you might need to perform before you can leave? Because again, the storm isn't a point. The uncomfortable conditions start happening well before the center of the storm crosses. If you stick your arm out the window going down the freeway, you might be feeling 65, 70 mile an hour winds. Technically, that's tropical storm force. That's not a hurricane. And we want you out of there before that kind of conditions get started. So one of the things for me from a scientific physical science perspective is just the size of the storm and the impacts that might have on people's decision making and understanding of what their risks might be. Something else that happened a lot were comparisons between Charley and Ian, because people like to think to something familiar. And it's easier to think to a storm that's happened in the same area, especially when it's eerily similar here. And these are covering the same time period, but we see that Charley is smaller and moving faster. It got there faster. So Ian had time to, more time over these warm waters. Like there are two different storms, and yet they followed a similar track. But that size does matter, both from a evacuation perspective, but also from just extent of impacts perspective. But again, it is easier to think about comparing storms when they do exhibit some similarities. I did want to point out again the size difference. So we've got estimated extent of tropical storm force winds on the left and estimated extent of hurricane force winds on the right. And these two panels indicate both the difference in size of the wind field and also how much more quickly Charley was moving across. Something I do want to point out here, and I have a QR code for anyone who's got a phone handy to be able to quickly scan it. This links to the NCEI summary of Hurricane Ian in their $1 billion disaster database. That particular summary has a wonderful overview of not just the storm itself, but its impacts. So it links to things like this map of the estimated wind extent, as well as observed wind speeds and wind gusts from the storm. And something I want to highlight here is that it wasn't just Florida impacted. It was also South Carolina. There was a huge swath of coastline affected by Hurricane Ian. And oftentimes people focus on the strongest landfall or the first landfall when this particular storm happened to impact quite a bit of the Southeast US, which complicates things from a getting in and helping people after the fact perspective. If people here need assistance while the storm is ongoing and impacting somewhere else. So I don't want to overlook the impacts that it also had on South Carolina. For example, the storm was larger. Yes, the maximum intensity was weaker, but the storm itself was bigger. Like the extent of the tropical storm force winds goes out of the domain shown here, implying that it's a very, very big storm. It doesn't look as organized on satellite imagery, but the wind impacts cover a greater area when you think about at least hurricane or tropical storm force winds. So the final thing I want to mention here before taking up any more time is just looking at the whole life cycle. It was disorganized initially. It took a while to kind of get going, but once it did, it was able to rapidly intensify, taking advantage of the large amount of energy available. And when it crossed Cuba, Cuba didn't really slow it down. But something that is important to think about is that slow forward motion across Florida, which makes a lot of impacts like rainfall worse. It also extends the time over which people are experiencing strong winds and can affect storm surge. So from a physical perspective, just the size of the storm was a big factor, and also what impacts the land had or didn't have on the storm are also interesting in thinking about what its ultimate behavior ended up being.
Wonderful. Thank you so much for sharing all of that. And I do want to highlight to everybody, and some of you may have recognized Dr. Kim Wood. She was our first weather band speaker of a breaking news event, which was the imminent landfall of Hurricane Ian. So Kim, thank you for doing that. And for everybody, we are looking to not only continue these breaking news webinars as they happen on the hurricane side of things, but we are looking at expanding that to other high impact events as well. So thank you. So with that, Our third speaker, Dr. Kim Klockow-McLean, is the social scientist and the human dimension side of all of this. So Kim, give us your initial thoughts.
Absolutely, and thank you so much for
We can see everything. That's good.
hearing me now.
Yes.
Great, thank you. All right, well, thank you guys so much for having me, and I'm thrilled to speak after the previous speakers. And I know coming from the National Severe Storms Laboratory, the work that we focus on here often is in severe weather, but from a social science perspective, there are a lot of questions that are common among hazards. And so I'm going to offer a reflection from things that I was thinking about, but things that I know other social scientists were also thinking about as Ian was impending. So one of the things that we always think about when hurricanes are approaching land is how are we communicating the various aspects of the threat? So one aspect, of course, is just who is going to be affected, where is going to be affected. And Jamie made a good point earlier that the cone of uncertainty maybe isn't the sole only important thing that people should be focusing on in terms of safety and decision making. But we know that it is something that's widely disseminated, widely used, and also widely misunderstood. This graphic represents historic track error. So forecasters offer their best guess of where the hurricane will go, and then the cone is automatically constructed around it. There are some times where a storm can have perhaps even less uncertainty than that, and some where it has a great deal more. And so this isn't necessarily a reflection of the forecaster's true beliefs in that way, and the endemic uncertainty to this particular storm. And another thing that's really interesting about this is it gives you a snapshot of the thinking in time. But as you go from this left graphic to the right, you see that there's what we call dprog dt, the change in a forecast over time. And so there are trends in how the guidance is evolving. What we have to understand about human decision making in these events is just as the storm is evolving in time and the forecasts are evolving in time, so too are people's thoughts about the event and their decision making evolving in time. And this is something we're really trying to grapple with in the social sciences, is that decisions aren't just made at one single point, but they're also made over the course of time. And how are people assimilating our forecasts into their own decision process? So something that was really important about this event was that change in forecast and resulted in an enormous sensitivity to potential impacts. We knew that changes in very small changes in where this thing could go could result in not only very different populations being affected, but very different kinds of hazard impacts along the coastline. So another interesting facet of this was the fact that hurricanes, as mentioned before, like there's sort of this conglomeration of a lot of different hazards. So yes, some people do need to evacuate. The people who are encouraged to evacuate largely are people who are going to incur storm surge threat. But with something like this crossing the peninsula as it was, as slowly as it was, we also knew there was going to be surge sort of coupled with rainfall, and there could be inland flooding hazards that resulted from it. And in that space, the decision making can be a lot more complicated. And so can the hazard communication. Just helping people to understand that's something they need to think about is really, really tough. So as this was unfolding, something that social scientists are also thinking about is that, in the physical sciences, you guys have so much information you're looking at to know how the atmosphere is evolving. You have these great models to couple with those observations, and you can sort of assess how well we're predicting this. On the human side, we don't collect observations in any sort of systematic way ahead of a storm's impact or even afterwards. I'll touch on that afterwards piece in just a moment. But it's hard for us to know what the impacts are of the communication choices that we're making because we don't systematically collect that information. Now, there was an experimental effort to collect some information from this storm from another colleague that presented at AMS. And it was a really interesting attempt. I'll say it did have some interesting caveats to it and the science of this. There's a science to how should we even collect these observations if we do? I think I would say that's still in a fairly nascent stage of development itself. We need to have the right kinds of instruments and the right kind of data collected from those instruments to make the right kinds of inferences. So what ends up happening is that this storm track does continue to shift slightly. So when you saw the graphics that other Kim just put up, you saw that what ended up happening is this, while this was always in a place where it was in the cone, it was on the sort of the right side of that. And how was that taken up? Did people make decisions in time that would get them out of this location in spite of that change that was happening over time? How was that taken up into the decision processes of officials and individuals in the way? One of the things that we could look at as the storm was impending is what's called social vulnerability. So not only are you concerned about where a hazard is going to impact, but you're concerned from the social sciences point of view about the characteristics of the populations that could be affected, because it's really the hazard times its consequences that creates impact. And these events are so much more consequential and difficult to adapt to for populations who are vulnerable. This map is showing what's called the Social Vulnerability Index. It's a conglomeration of a bunch of different factors. So it can be tough to understand, well, what exactly is the specific driver of vulnerability in this area that did get hit? A lot of it is older populations, and we have some concentrations too of poorer populations. And, so the ability to evacuate is certainly in question for the populations that were most directly affected. And for a lot of those populations, they actually would need more time to evacuate because of those challenges with mobility, health, and access to resources. So the human toll of this, unsurprisingly, was that the intersection of the worst physical hazard with the highest vulnerability is where we saw the concentration of fatalities. And it included both surge-related fatalities along the coast, as well as there were drownings inland. That complicated scenario that we were talking about, this is the convolution of many different kinds of hazards going on. There were a lot of fatalities from a lot of different parts of the hurricane and the hazards that it generated and its associated complex impacts. Something I want to note about what I'm showing here is this was actually information given to us from NBC News. They went out and did a really deep, what I would consider to be almost a true disaster epidemiological analysis of the storm and its impacts. They went through, they interviewed family members of those who survived, or those who perished, to try to get that full data of, okay, what were the circumstances of the death? What were the decisions that led them to be in that vulnerable place and not evacuate if they didn't evacuate? And they found, really stunning evidence about how our forecasts were taken up in time and used to make decisions or not, the role of public officials in the decision process, and the intersection of vulnerability and what resources people did or didn't have. And I think it's striking to me that when we do get these kinds of analyses, they often are coming to us from things like media. And it's not something that we internally yet, at least, have any way to do within NOAA. We're not collecting that kind of rich epidemiological evidence in the wake of events like Ian or others. And there's so much to be learned from that, but it's not a capability that we have either. So I'll conclude by looking ahead and just sort of saying, where can we expect things to go from here? Not only was this a particularly vulnerable area, it also is defined by the National Risk Index put out by FEMA and actually information generated through the US Census. This area has a low capacity to adapt and withstand and recover from disasters. So when Jamie was talking about that story not even being done, it's still not. The full impacts of this are likely going to be realized in just years to come. And so while we're concerned about fatalities and preventing those, broader impacts certainly have a wide set of things to be concerned about. With that, I'll pass you back to Doug.
Yeah, thank you, Kim. And, a great way to kind of end the three of you speaking is this, people even right now are still being impacted, still suffering, still trying to get their lives back together. And our sort of drive to have a quick answer to this has to be kind of ameliorated to just let's get it right. Let's serve these people, and over time we will come to the realization of all that has been impacted here. So we do have one question, and I invite everybody to not be shy and to insert a question if you have one. I have a few questions as well, but let's start with this. And I think this is directed toward Jamie. So I don't know, Jamie, if you're able to see the question in the Q&A, but is there a possibility that the wind field forecast within the National Hurricane Center forecast advisory could be added to the interactive map, as it does not show the forecasted future winds?
Actually, we do that for the initial winds. So the initial winds are a component of the most recent cone, and it speaks to. So I'm going to get back to your question, Doug, but I want to finish this line of thought. One of the things we're doing with the cone over time is trying to overlay, more and more hazard information. But the hazard information is so complicated that if we overlaid all of it, then it would be a jumbled mess. So you're trying to thread the needle there. But the initial wind field is on the cone. The projection of the wind field is something that the dynamical mesoscale models are just now starting to get relatively skillful at. So while it hasn't been really, really good in the past, I think we're probably on the cusp of maybe getting to the point where we can do a better job of communicating the future structure of a storm. It's one of our big research and development thrust areas going forward. So if you look back over the last 10 years, the first big thrust area was improvements in track. We kind of, we've made that big push, and then it was improvements intensity, especially rapid intensification, and that was a massive accomplishment during Ian. The ability to predict and communicate that rapid intensification spell was, for me, that's been here this long, was shocking to see it unfold. And now I think our next big thrust over the next 5 years is the ability to forecast and communicate the structure, because I think that will help us get to what social scientists are telling us to do, which is localization of the threat. Right now we broad brushed the threat, at least at the Hurricane Center, and the ability to drill down and provide a bit more localization of the impacts and threat will, I think, help people personalize it better and take action.
Now, question number 2 may be directed at Jamie, but I think the Kims, we may, if you have had any engagement on the extreme wind warning product, certainly chime in. But now that it's over 6 years since it went operational, any insights on how well the extreme wind warning product is working in communicating the wind threat?
I think for what it's intended for, it's working well. One of the challenges with the west coast of Florida is the surge often arrives well before the wind, and may cut off evacuation movement. And that's indeed what we heard is, a lot of people don't move, and Kim can elaborate on this. A lot of people don't believe the hurricane is coming until it's there, until they can see it with their own 2 eyes. So I think a lot of people waited until it was right on them, and then tried to leave. And by that point, the surge had already cut off evacuation routes. So one of the questions before us is, do we need something akin to the EWW but for surge? I mean, do we need something like a storm surge emergency, or something to that effect, to make one last? So our surge watches and warnings are long fused warnings, meaning they're issued well in advance of the threat to try to prop up evacuation protocols and orders. But do we need something short fuse that is basically, you know, in the hours before, to try to push those last few people out of harm's way? And that's something we're deliberating on as we speak.
Kim, any seconds on top of that answer?
I'll just say, you know, Jamie, and Jamie's well aware of this, that yeah, there is definitely hesitancy for people to evacuate unless they are both reasonably sure that they can and that they need to, and that they have the resources to do so. I think something that we need to be sure of in events like this is how much of what happened was because people weren't sure that they were going to be the ones affected until a certain point, and how much was about the capacity to evacuate. I think one of the things you see in the post-disaster narratives that were reported is it's a little bit of both. And so, you know, one of the things that could be interesting is for us to think about the degree to which how are we communicating what at that time scale when people need it? Are we effectively communicating that it really could be you? I mean, there's something there where people really struggle to personalize the threat to themselves. They believe, yeah, there's a hurricane there. It could be really, really bad. But making that step to making the connection to their place, oh, it could be here. It's a challenge for hurricanes. It's a challenge for other hazards too. There are actually entire bodies of what my colleagues have come to term folk science that have built up around this, where people feel a sense of invulnerability of the place they live in to different hazards. It happens here in Oklahoma about tornadoes. I live in a town where the people, a large share of the population doesn't believe Norman can be hit by a tornado. And that's incredible for a place embedded in central Oklahoma. But there are a lot of reasons for that. And that actually, those narratives you hear in Florida as well. And some of us were concerned about Tampa and Fort Myers because there had been recorded when Irma was coming, there had been news reports where they interviewed people and they're like, you know, they talked about that same thing. Oh, well, this place, it's not just that we won't get hit. They believe there are reasons, like physical reasons why they can't get hit. And so it's a really interesting intersection between the cognitive piece, the reasoning piece, and the capacity. And to dismantle, to really handle all of the things that we're fighting to make our communication effective, it's a really big challenge. So I'm glad you raised that, Jamie.
Thank you for that. All right, we've got people not holding back, which I like. I think this returns back to Jamie, and I'm going to try to massage this question a little bit. Has the NHC thought about embedding the probability intensity contours within the probability track projections?
Yeah. You know, first let me say we've thought about and tortured ourselves with every imaginable idea. I mean, this is very personal to our staff. To have any storm, any mortality is soul crushing, and then to have one like this that's, you know, relatively high is really difficult on our staff. But as Kim alluded to, you know, we need to resist trying to solve a multidisciplinary problem with a single discipline, which is historically how the Weather Enterprise wants to tackle this. You know, something was wrong with the weather forecast, and so if we make the weather forecast better, it'll make it, you know, everything will go away. But you know, Kim talked about this. This particular community, especially, there are significant barriers in place that, you know, I could have run through the streets with a banner, you know, and it wouldn't have mattered. So until we can really understand that component and factor it in I want to be hesitant not to over-engineer a weather solution and make sure that we're being, and that's why I'm so patient with this. If you saw the Q&A I did after Ian on the cone, you see a very deliberate, patient approach where I want to make sure that we're, number one, letting the full data of the disaster reveal itself, right? Let's ground ourselves in fact finding and information. And two, tackle it from a multidisciplinary perspective where we're bringing social behavioral experts to the table and including some of the elements that Kim talked about, the social vulnerability. This particular part of the coastline is very much older than other parts of Florida. And there are really, really good reasons why people didn't evacuate, even though they knew. You know, if you had a chance, I've actually gone over and talked to people in the impacted area and surveyed the damages. There are lots of examples of people who absolutely knew it was coming, but there were many, many, many barriers preventing them from taking the action that we would hope they would take. And I'm sure Kim's got something to add to that.
All right. Next question. We're kind of transitioning to now observation systems. So I'm kind of looking at Kim Wood here. As a researcher, there's no data that you don't like. But they highlight, you know, what if you had a wish list and the specific question is really targeting the Caribbean, thinking it's, you know, not as data rich as, you know, certainly the continental United States. Is it radar? Is it, you know, taking satellite data and building an application out of it? What's sort of your wish list when it comes to the Caribbean area?
So for observations, my personal wish list, so I say this because I am an observationalist and I use a lot of remote sensing data. So I'm not speaking on behalf of the entire weather enterprise as far as this wish list goes. That said, one of the challenges we have for observing the tropics is just the wide swath of ocean. We can't park a whole lot of ground sensors across because it's just ocean. There's no place to put them. And so what would be ideal would be to have a lot of satellites that are orbiting closer to the Earth, what we call low Earth orbit, that have sensors on board in the microwave part of the spectrum. It doesn't mean they're sending microwaves down. It just means they're able to see that. And those wavelengths can like peer through the tops of storms, almost like an X-ray, to see the structure underneath. And so if we had more of those satellites, then we would see a storm more often. There are efforts moving toward this. The Tropics mission, for example, has a bunch of CubeSats, the little small sats, that are supposed to fly in sequence so that we can reduce the time lag between observations and thus capture glimpses of those inner processes. Like Jamie was alluding to earlier, a lot of research has gone into studying rapid intensification. And so we know a lot more about the processes that can contribute to it, but we still want to see them. And so having a lot of satellites in the same kind of orbit, but like one after the other, would give us more snapshots. And potential benefits of that over, say, ground radar can be hit by hurricanes. And so if you're wanting to observe a storm, it's kind of nice when the storm is not impacting the sensor. And then when we have a lot of observations from space, if we can concurrently have aircraft with lots of instruments on board flying through, especially if they're with some of our emerging technologies like sail drones and the unmanned systems that can fly inside the eye for 2+ hours and just keep grabbing observations close to the surface, that kind of gives us that vertical extent a little bit better, plus the horizontal extent, and then changes over time, because really a hurricane is a 4-dimensional phenomenon. So I know that was kind of biased towards satellite imagery. Having more radar would be helpful, but when they are parked on the ground, they are limited by if there's terrain in the way. You know, Cuba and Puerto Rico have mountains, and so that can block the lowest level of the beam and that sort of thing.
No, it's certainly good to highlight the aircraft observations, and the job that the hurricane hunters do. I'm going to shuffle the Q&A a little bit here and stay, since you're the observationalist, I love that term. And I always chuckle when people will give a rainfall total from a hurricane that, it's really, I think personally impossible to accurately, have a surface rain gauge, give how much rainfall there is in a tropical system like that. So looking at it from a sort of a remote sensing, what are your thoughts on when we see these rainfall totals?
Oh, well, remotely sensing rainfall is imperfect. We are looking at from outer space down to the tops of the clouds and then have it to see through those clouds to estimate how much is falling. We also ideally are trying to distinguish between rain type. Now, that's not usually a big deal in a hurricane, it's all rain, but there are ice crystals, there are frozen things inside the storm above the freezing level, and that can impact how we retrieve information about what fell. So ideally, we get good observations inside a storm, and we can use those ground observations to compare with what we get from space to make the algorithms that we use with those space observations better. I think there was a comment about CoCoRaHS, and I was looking at that earlier, and they were seeing some values 12 plus inches. And one thing to think about when it comes to measuring rainfall is ideally the rain's falling straight down. And that's not necessarily happening in a hurricane where you've got very strong winds that are varying quite a bit over the rough terrain. And so there could, for a given, area of rainfall, there actually might be contributions from the sides that didn't come straight down and thus produce higher totals than actually fell in that spot. So the process of correctly measuring rainfall at the ground in a hurricane is complicated, just as trying to estimate those rainfall totals from space is complicated.
Yeah, no, often is the case. For the other Kim and for Jamie, anything on the topic of observations that you want to say?
Yeah, we often in situ observations have never and will never measure peak disasters. To write it on your board. After every disaster, there is an insatiable appetite to pillage through the in situ observations and try to make a conclusion, but they can't and won't measure the event. They'll measure aspects of the event, and they certainly contribute to a final analysis. But there tends to be an over infatuation with observational systems. And I was in storm surge for 13 years, and it's especially pronounced in storm surge, and probably equally as bad in rainfall in some cases. But if we're forecasting a storm surge of 15 feet, you're not going to see an in situ observation measure it. You're just not. And the way we do it afterwards is we still use this really old school method of damage surveys to get at the peak surge, just because in situ observations are too infrequent and often fail in such extreme conditions.
Interesting. So the next question, what comes to mind when reading it, and I appreciate the passion behind the question or the series of questions here. When we talk about hurricanes, and you'll see this on social media, it's not a natural disaster, it's a human disaster, where we have large condominiums built right up against the seawall, fragile ecosystems, barrier islands with a lot of people, a lot of commerce. And so just highlighting building codes and just, the insatiable appetite for your beachfront property. as well as, sort of the, there's a lot of good over social media when it comes to these big events. But there is a lot of, hype and, people preferring clicks over, really educating the public. And so I guess I'm looking at Kim Cloko McLean. Your initial thoughts on this question?
Way to ask the deep philosophical questions, guys.
It's gotten real here at the top of the hour.
Yeah, we're getting real. These are the things that, I mean, it is so frustrating from the perspective of the meteorological community to think about something as being beyond our control. But those are the things that in real time we should sort of have to take as fixed. But in the long run, everything is changeable. So it would make sense to ask, why can't we just remove people from a place where they are hazard vulnerable? I'll say that the one framing of this. So I have a background in economics, and one of the things that we always talk about from this perspective when confronted with this question from the meteorological community, well, why doesn't everyone just protect all the time, is there's a really big opportunity cost to doing so. So what you're arguing with that is that people should forego living in a beautiful place that doesn't incur hurricanes very often, so, for that one moment where they do. And so I think there actually is a really interesting question in there about what our society should do in, the wake of this very real trade-off between a day-to-day, utility and well-being and protecting itself from catastrophic risk. One of the things that we participate in the weather community is just getting people out of harm's way. So we can try to save lives. And that's one, you can think of that as like the lowest level patch to the problem. As complicated as it is the lowest level patch. What you're thinking about is a bigger infrastructural question. It's being addressed, though, in other ways by our government, because for a long time, one of the reasons we had so much buildup along the coast was we had a flood insurance program that grandfathered people along based on, if you had an old flood map that underestimated your risk, your flood insurance premium could be fairly low. And as science evolved and we actually figured out risk, was worse, those properties, we wouldn't raise their rates. So people weren't paying the full risk rate on these higher risk properties. That has been reworked in the National Flood Insurance Program, and people are starting to have to pay for the full risk that they're exposed to. And I think if you look at this case with Ian, there were a lot of properties involved that were old. And I would venture to say that, initially this had been people who were living there, who were not in a position where they had to really think about bearing the cost of the weight of their risk. And now they are, and it certainly will be part of rebuilding. Any structure that is rebuilt, if it's destroyed past a certain amount, they're automatically booted to the full risk rate. So a lot of these properties won't be insurable. And that's actually one of the big conversations in Florida is, are we going to lose these communities entirely because it's unaffordable? So what you're suggesting is, well, shouldn't we do this? Well, some people might say so, but you have to also admit that there's a real heartbreak in losing communities. So a tough problem.
Yeah, and again, with we always think back to the real game changer was Hurricane Andrew, especially in Florida. And Jamie, I don't know if you have thoughts as a resident there down in the Miami metro area, but again, getting to Jamie's point of we got to work through the long-term impacts of all of this. It'll be interesting to see how Ian is a game changer on top of Andrew there.
I think it's going to bring about building code changes, as it should. The longer I've been in hurricanes, the more I realize that a bulk of this is, not to Kim's point, not forcing people to leave, but if they're going to stay, we need to harden what they're staying in. And building codes are a remarkably effective measure. And I've surveyed major hurricanes for years now, damage surveys. I mean, I've gone into some of the worst imaginable conditions you can dream. And I've always been struck by you will see utter carnage juxtaposed by houses that you can barely tell anything happened. And it's amazing how a modern built home, if in the surge zone it's elevated, how well it does. I mean, it's absolutely shocking. And I mean, even in Ian, I can remember just looking at total and utter carnage in a trailer park that was right on the coast, right in that 10 to 15 feet of surge, just utter, I mean, just the most unimaginable, awful thing you could look at. And then seeing a house that I could barely tell other than some debris thrown around in the yard, you couldn't even tell anything had happened. And it's just shocking. So I think building codes are a very effective measure. Retreat is just not something the U.S. is ready for. Retreating from these coastal communities is just not, we're not there yet.
No, I would certainly agree with that. All right, so we're coming up on our 10-minute mark. We've got a lot of great questions here. So we're gonna kind of go into a speed round here. Dear friend of mine, Rick, do we know why NBC did such an in-depth post-storm epidemiology? And can or does NOAA work with these media and even the local media on some of these studies?
I'm wondering, Jamie, if you know the answer, actually.
Yeah, we're actually trying to do a better job at the Hurricane Center. This is largely something I'm passionate in, started Storm Surge, at tracking mortality, because you can't improve that which you can't track. And historically, mortality in disasters was just a bulk statistic. This many people perished, and you didn't know how or why. You didn't know their stories. You didn't know if they died immediately or died 6 months later from depression. And so we're trying very, very hard to do a better job of mortality. Obviously, we haven't released the Ian final report, but we have mortality information internal here that we're cranking through to try to pull out a narrative that would inform future decision making with respect to hazard communication. It's a relatively early effort, and this information is doggedly difficult to find. Nobody's going to serve it up on a plate for you. You really have to go after and find it, which probably speaks to why the media is preceding the government, because they probably have the resources to do the investigation necessary to find it.
I think just from the perspective of social sciences, where we're one of the things that I'm working on trying to do is bolster this same thing for severe hazards and understand tornado epidemiology, for example. It is really, really tough. And, so there's some things in public reporting that are available that are instructive, but it's actually not common to do what is needed to collect the full set of the data. So one of the things you need to do is things like informant interviews, which broadcast media are trained to do, right? They interview people. They're really good at that. But you can have, in the social sciences, we do that too. Those more qualitative methods. I think part of it for NOAA is just asking ourselves if this is something we want to have in-house and shore up as a fuller, capacity. If we could, theoretically do it, it's a really interesting challenge. Something else I'll point out, though, is we always need to be aware that the number of deaths in an event doesn't at all tell the whole story. So one of the things that we always neglect is actually to count survivors. So part of the epidemiological analysis isn't just how did people die, but how did people survive and what was the fatality rate? I think in the wake of COVID, we're more accustomed to thinking about fatality rates maybe than we were before, but that's actually a really important piece of this. We need to not just look at what failed people, but for what fraction of the people were actually failed. It could have been that 95% of whatever, even a vulnerable population, did have success. And so you need to have all of that information so you can actually know if you need to make a policy change. But we don't. So we don't collect a lot of that. I think the media, as Jamie was saying, yeah, they have the resources. I would argue also the training, and just they go out and they do interviews as part of their day to day. So yeah, it was easier for them to tell that story earlier, but it's something I'm really interested in, and I've been thinking about. We could cultivate a disaster epidemiology that's sort of the social scientists and physical scientists working together.
And I want to jump in on that real quick. What Jamie said earlier about how the data, the observations cannot capture the scale of the disaster, human stories can. We need the context of what humans experienced to know what to make of the data. I can use satellites to estimate, how much rain fell, but like, did it fall in a swamp or, on elevated land? Was there surge in there also impacting things? Was the ground already soaked? Did somebody just rebuild their house versus was it under renovation, or could they not afford, small things comparatively to improve, their building standards? Like, we need these stories to give context for the work that we do on the physical science side. And as a teacher, the stories really help when students are, trying to learn the physics of these things. They get to see how it relates to impacts and thus what it does to the people experiencing them.
I love that. No, very, very well articulated there, Kim, and everybody. And it's, kind of, if there's any takeaway from this webinar, I think we've hit the nail on the head there. Again, we're coming up on a couple of questions, but only a couple of minutes. And so some of these we'll have to capture offline. Jamie, just real quick, how did Ian's intensity and track forecast compared to the other biggies from the year previous with Ida and Laura?
The intensity forecast was one of the greatest scientific achievements I've seen in my career. The ability to anticipate rapid intensification like that, and more importantly, the confidence of the forecasters to aggressively communicate it. It's one thing to see it internally, like in a model or something like that. It's quite another to go out on a limb and communicate that strongly. Was one of the great successes of this storm that has not been told. And given the storm surge vulnerability and the social vulnerability that Kim talked about, I hesitate to think what would have happened in this event had we not been so aggressive with the forecasting. The track forecast was about on par with 5-year historical errors. So it was neither notoriously good or notoriously bad. A lot of people like to make it out like it was bad because of the acute angle of approach on the Florida coastline. The small deviations in the track vector made for large geographical changes, but the forecast itself was about normal in terms of accuracy. And we'll be showing that verification of those plots in upcoming conferences and reports. If people don't believe me, that's fair. But I think the intensity to me was just absolutely shocking from a scientific achievement.
No, something historically we struggle with, and so important on all of this. One last question we'll take, and having literally lived through Hurricane Floyd while at NC State, being in grad school for less than a month, and such a historical storm on the freshwater flooding side, a lot of lessons from Hurricane Floyd in 1999. But for Ian, any thoughts on, what, especially on the communication side of things, what were some of the lessons learned or takeaways from Ian on the freshwater side?
I'll go quick and then throw it to Kim. This is where tracking mortality, I think, really helped us. Know from past events that we're losing more and more people from inland freshwater flooding. And based off that knowledge, in the newer products produced by our sister center, the Weather Prediction Center, we pounded the pavement hard. I mean, really, really, really hard on the freshwater flooding potential. And I really think that brought down mortality along the I-4 corridor, which experienced a ton of rain.
Yeah, that's where it is so important to know things like base rates, how many people could have been affected and did successfully mitigate a threat. We know that there were people who perished, but yeah, that's the tough thing. I know one of the things about this that's so difficult from the communication perspective is people want to have some sense of what's going on and why it's happening. And uh, I haven't had the chance to delve into the inland flooding piece for Ian, but I was on the service assessment team for Harvey. And one of the things that was just so interesting was the fact that you could be in a place where it wasn't necessarily even raining right on you, but the water still was pooling and backing up, and it couldn't drain effectively. And people don't think about all of those things of it's not just about water hitting the surface, but what it does once it's interacting with the landscape that produced the inundation. And so everything that we're doing to just talk about where the storm is and where the rain will fall, all those emphases sort of fall short of connecting with where the water will go and how high it will be as a result, and decoupling those things of what's going on from the atmosphere versus what's going on the land. I mean, it's part of what Jamie worked on with storm surge. You kind of have, what's going to happen to the land is the consequence, and that's the thing that really matters. And I think we need to continue to push into that a little bit with inland flooding. And there's work going on to try to improve the modeling so we can even show, have something to show people, because the visual can really make a difference. But it's a wonderful, this is just one of the most challenging areas in what I see in communications is flooding just in general, but specifically inland flooding and hurricanes.
Great. And Kim Wood, any last thought on your end?
All I'll say is getting feedback from people is really important in thinking about how we communicate things both with words and with visuals. And I'll just also shout out how much behind the scenes testing and discussion goes on before new products come out. There's always things that could be done better, but they do a lot of vetting and training and to make sure that the products are good and understandable before they end up with the official NHC logo on them as, NWS products.
No, a great last message there, Kim. So thank you, everybody. We're a little bit over time. We have our third and final Jamposium webinar for the day, starting at 2:30 Eastern Time. Again, we have 3 more sessions tomorrow starting at noon Eastern Time. But I want to thank our panelists so very much and all the great questions from the participants here. I know I've learned a lot more about Hurricane Ian moving forward. And I hope all of you have found this interesting. Thank you so very much. And we'll see you at the next session.